Okay, hello everyone. Welcome to a new course on digital image processing, also known as image processing and pattern recognition. This will be very beneficial for those who are looking for a course that will cover everything that will come in their semester examinations. Whether you are a BTech student or an MTech student, this will be very useful to you for your semester examinations. So without any delay, let's move to our first topic. So what is an image? What do you understand by a digital image? A digital image is a collection of discrete data points called pixels that represent both the spatial, positional layout and the intensity, color or brightness information of a scene. It can be thought of as a multidimensional signal that carries visual information. Look, a digital image is nothing but a grid, okay? You can think of it like a grid where each data point, like if you have read about grids, then you must be known, or if you have ever read about graph, then you might have known that there are two axes, right? X-axis and y-axis. And if we draw a line on x-axis and y-axis, then there is a point, a dot. That dot is called a pixel, okay? So here that x-axis and y-axis is a layout that is known as spatial or positional layout, okay? And that dot, the line that is creating that dot, the intensity value or color or brightness value of that dot is known as intensity, okay? And these two things combined create a digital image that we see every day in our life. So in below image you can see that there is a grid, okay? That grid is called spatial data or layout, and on that grid you can see that there are one points, okay, specific points at each intersection of x and y axis. That point have some intensity value, okay, color or brightness, that is known as intensity data, and these two things create an image. Okay, so let's move to our next topic, the digital image layout. Okay, what is the layout of a digital image? A digital image denoted by IM, N is a two-dimensional grid of data points that records a sensor response like brightness or colors at a series of fixed points. Look, as I told you in the previous slide, a digital image is a collection of like it is a grid basically, okay, where x and y axis intersection of x and y axis is creating a point called pixel, and here it is denoted by I m comma n, where m is representing x axis and n is representing y axis, okay? So it is a two-dimensional grid of data points that records a sensor response, like suppose the sensor is a camera, okay? So it is capturing some images, okay? So it is capturing the brightness or color of that specific point in this 3D world, okay? And that is capturing and creating a digital image out of it. So discretion, what is known as discretization, okay? This grid is created by sampling a continuous physical signal I, x, y. A process is called discretization, okay? So this process is known as discretization, where we capture some a brightness, we capture a brightness at specific point, okay? Think of it like a digital camera where the continuous light is averaged over a small square areas. Suppose that there is a square area, okay? A pixel is what? A point. You can represent a point as a small square area, right? So think of it like a camera is capturing what is the brightness level at that area, what is the brightness level at that point or square. That is also only known as discretization, where we capture every we capture the brightness at every point, and then we combine it and create a digital image out of it. Okay. Pixel, each individual data points is a picture element. Like I told you before, every data point that we create out of x and y axis, the point that is created by the intersection of x and y axis is known as a pixel. Okay, uniquely identified by its position using the two-dimensional index m comma n, where m is the row and n is the column. Like I told you, if you take a page, okay, and you draw a x-axis and y-axis, then their intersection will create a point. Okay, that point here is denoted by m comma n, and that point is what called as pixel, where m is representing the row or x-axis and n is representing the column or y-axis. Origin, the image grid typically indexed from the top left corner. So basically the default value, like the default nature of an image processing is like when digital image is processed, then pixel like indexing or creating a pixel starts from the top left corner. Okay, this is a rule. So let's move to our next topic, abstract and higher dimensions. While we usually deal with 2D images, the concept is flexible. Like we see every images, like every images that you capture with the camera, what is that? A 2D image, right? But it is not limited to just 2D image. Like you might have seen nowadays there are 3D images, holograms and many things. So it is that digital image processing is not limited to 2D images only. Okay, continuous versus discrete. Although digital images are discrete, they are sometimes treated mathematically as continuous signal I x comma y to apply calculus for analysis. Look, like a pixel is a one unit, right? So it is a discrete value. What is discrete? Discrete means a complete, like one value. And what is continuous? It means it is in a continuous value, like 1.555, that is continuous. Okay, and discrete means one, like a whole number. Okay, so a digital image is like discrete. Okay, by default it is discrete, but sometimes for our analysis, for if we have to do further analysis, like the scientists they do analysis on images, right? So they treat as a continuous signal as well, so that their analysis can be easy. Okay, higher dimensions, the idea extend to more than two dimensions. Look, as I told you, the 2D digital image processing is not limited to 2D. Okay, so we move to 3D and 4D also. A 3D image, a volume like medical scan, has voxels, volumetric pixels. Look, if you have seen an MRI scan, right? What is that? A 3D image. You can see internals as well, right? Internal organs as well. So what is that? A 3D image. So in 3D image, we don't use regular pixels that we use in 2D image. In 3D image, we use voxels. Voxels means volumetric pixels. Okay. A sequence of 3D image over time, like beating of heart, can be treated as a single 4D image, three spatial dimensions plus time. Look, if you have know about animation, like previously when there was no technology to record a video, then what people used to do, they used to create many images and then they used to move it faster so that it acts like a video. So here also we use many 3D images, okay, and we move it fast so it behaves like a 4D image. Okay, like if you are doing an MRI scan of a beating of a heart, okay, so we will capture many images, like 100 or 200 images, okay, and then we will move it fast so that there are already three dimensions, okay, x, y and z, that is height, weight and depth. Okay, but if we are moving these images fast, then one more dimension gets added, that is time. So it behaves like working as a, like, look, it looks like an video, but it is actually 3D images moving very fast. Okay, so let's move to our next topic, image color and channels. So every pixel location IMN is in an image has one or more channels that define its intensity or color. Look, every pixel, like I told you, pixel is a combination of x and y axis. Here it is denoted by m comma n. So an image has one or more color channels, like like previously we had black and white images. Nowadays we have color images, so it has more than one color channel. Okay, the two we know is black and white and color, and there might be more. Okay, so single channel images, intensity image. Single channel images, what it means, you can simply think of it like a black and white image. Okay, intensity, it is also known as intensity images. Okay, data, the simplest case uses a single numerical value per pixel representing the signal's intensity level. So here, like, there is one pixel. Okay, and that is either very bright or very low bright. Okay, look, right, what is light? Light is a color of light is a white color. Okay, however, it is a combination of Vibgyor, what we see it as a white color. Okay, so there are two colors only, white and black here. Okay, and the intensity of the white and black creates more images. Okay, more depth. So the simplest image, so the numerical value per pixel. Okay, numerical value per pixel is representing an intensity value that is creating a image. Okay, what is color map? Color map, to display these numbers visually, a color map is used. This map assigns specific color or shade to each numerical value. Look, what do you understand by a map? A map is something where we can locate things. So a color map is something where we can locate colors. Okay, in a grid. Okay, and this map assigns a specific color or shade to each numerical value. Like each pixel, you can understand here numerical value as pixel, so it assigns each pixel a specific intensity of color. Okay, and that create an image. Grayscale, the most common color map, assigning shades of gray from black 0 to white maximum intensity. It's ideal for intensity images where the signal is purely about brightness. Look, what is grayscale? It is simply black and white. You might have used filters like that nowadays in Snapchat and everything. Okay, so what is grayscale? It is a combination of suppose there is a black, it is assigned a value of 0. Okay, there is a white, it is assigned a value of 1, and in middle there might be a little bit white, a little bit black, right? Those are assigned different values, like shades of gray. Okay, and these all sets in combination create an intensity level, different intensity levels of each pixel, and it create and we adjust it accordingly to create an digital image. Okay, false color. What is a false color? This map assigns color other than grayscale shades to the intensity values. Like, means false color, you can understand, like there are two color. Okay, 0 means black and 1 means white, and in between, as I told you, a little bit white or a little bit black. Okay, you can also tell it as a gray color. So what is that? It is a false color. Like it is a combination of the two, right? It is just white, but its brightness level is little low, or it is just black but its brightness level is little low. So it is false color. It is not actual. Just this is the game of brightness, right? So that's why it is known as false color. So what is the purpose? What is the purpose? It is often used because the human eye is much sensitive to different color differences in colors than differences in gray shades. Okay, like only about 40 shades of gray are discernible. Look, we as a human, if we see an image, if we see more colors, then image is more clear to us, right? So that's why we use this false color. Okay, so that we can create different brightness levels of this color, different shades of this color. Okay, so that we can more visually see that image. because it is the human eye nature. Okay. That's why it has been like that. And what is its benefit? It helps us to capture more, like false color highlights or accentuates specific features or structures, making detail easier for a human observer to spot, common in medical and or astronomical images. So what is its benefit? Like, as there are different shades, so we can use this shades to like, in border we will use a little gray, in eyes we will use a little black, so we can differentiate, right? And this helps in many cases, like in medical or astronomical images, like MRIs can, or you are taking an image of Mars or an asteroid, so it is very helpful in those cases. Okay, so let us move to our next topic: multi-channel images, true color images. So look, multi-channel images, why it is called true color images? Because it is color. You can simply understand it as a color photo. Previous was a black and white photo, and this is a color photo. Okay, so what it is, let us understand. Data. True color images represent the full spectrum of color using a triplet vector of numerical values at each pixel. Look, if you know about colors, then you might have known that every color that we see in this world is a combination of three colors, that is red, green and blue. It is called RGB. Okay, so what data is used in multi-channel or true color images? We use this RGB to create different spectrum of colors. Like every color possible in this planet can be created by these three triplets. Okay, representation, the most common system is RGB. As I told you, RGB, red, green, blue, it is used to create many different colors. Okay, the final color is a linear combination of these three basic colors. Whatever color you are seeing, purple, any color, these it is combination of these three colors only. Okay, structure, a true image color can be mathematically viewed at a three separate 2D planes, one for red data, one for green and one for blue. Look, what is the structure of true color image? You can visualize it like you have three filter. Okay, one is red filter. You can try in your home also. Just buy some red filter, one green filter, one blue filter, and place it in one above another. You will see that it will create different type of images, different shades of images. Okay, so it is a basically it is a 2D planes, one above another. Okay, according to what color we want. Okay, alternative color spaces, there are some alternative color spaces as well, like HSV stands for hue, saturation and value intensity. Like hue is what it, you can understand it as a fog saturation, like you can completely understand it as like a fog. Okay, that will blur your image a little or it will not blur according to its level. Okay, it is also, it is used sometimes if we want to further like edit our, like in advanced photography we use these things. In HSV, intensity V is separated from the chromatic information which is contained in hue and saturation component. So these are like intensities are separate from hue and saturation. Okay, these are just basic things. You can understand it is like a fog and for an image, and you can manage its intensity. So that was it for today. We will cover more important topics in the upcoming lectures. I hope you liked the video. Subscribe to our channel. We create playlist on every topics that are in computer science, like artificial intelligence, database management system and everything. Okay, so keep subscribed to our channel for just simple explanations like this of any tough topic. Okay, make sure that you like our video and subscribe to our channel and share this video as much as you can. Thank you.